The human mind, by nature, constantly seeks limits. We ask what the highest mountain is, and we find Everest, a wrinkle in our planet's crust, whose summit we can visualize, whose storms we can imagine. We search for the deepest point, and we find the Mariana Trench, a scar on the seabed, so deep that the highest mountain could sink into it without a trace. Despite their scale, these are dimensions that, with effort, we can comprehend. They are the limits of our world, but not the limits of our understanding. We look up and see the solar system. Jupiter, a gas giant so vast it could contain all the other planets inside it. The Sun, a star of modest size, yet so large that 1,000,000 Earths could fit within it. Here, the numbers begin to escape our intuition. The mind can process the number, but it can no longer truly feel the scale. We extend our perspective even further. We travel for 4 years at the speed of light to reach the nearest star, Proxima Centauri. We cross 100,000 light-years just to traverse our own galaxy, the Milky Way, a city of 200 billion stars, each a sun, many with their own planets. At these distances, kilometers become useless, and light-years become mere markers on an unfathomable map. And yet, our galaxy is but one of 2 trillion galaxies that populate the observable universe. Each of them is an island of light in a growing ocean of darkness. At this point, we have reached a place where the scale is not just large. It has become abstract, a form of mathematical poetry. We believe we have found the limits, the monsters that inhabit the edges of the cosmic map. But the universe always has one more surprise, an object that resides in a category so extreme that it shatters even these astronomical scales. An object that is not just bigger, but fundamentally other. A giant that not only challenges our imagination, but annihilates it. Before we cross the threshold into the truly incomprehensible, we want to take a short break to connect with our crew. We would love to know from which city or country you are joining us on this journey to the confines of knowledge. And if you enjoy these deep explorations, consider subscribing so you don't miss any of our future expeditions. Now, with our crew assembled, it is time to continue. Tonight, our journey is not to a star nor to a galaxy. It is a journey to an anomaly, to a point in space-time so massive, so violent, and so luminous that the laws of physics as we understand them bend around it. We embark on a journey of more than 10 billion light-years to meet the undisputed king of cosmic giants, the most voracious and brilliant object we have ever discovered. Its catalog name is simple, almost anonymous, TON 618. But behind that designation lies a black hole of such an inconceivable mass that it defies our theories on how these monsters can grow. A black hole that, in its feeding fury, has generated a quasar, a beacon of light so powerful that its brightness is equivalent to that of 140 trillion suns, eclipsing its host galaxy to the point of invisibility. In this audio documentary, we will not only tell you the facts about this titan. We will try to build a mental image of its scale, explore the paradox of how the most absolute darkness can generate the brightest light, and travel back in time to see it as it was when the universe was just a child. This is the story of the limit of imagination. This is the story of TON 618. To begin to understand the true nature of an object like TON 618, we must first familiarize ourselves with the most extreme concept in the entire cosmos, the black hole. It is not an object in the traditional sense, not a sphere of matter, nor a vacuum. It is rather a place, a point in the fabric of space-time where gravity has become so immensely powerful that it has collapsed in on itself, creating a well from which nothing can escape. Imagine the universe as a vast, taut sheet. A star is a marble that creates a small dent. A planet, something even smaller. A black hole, however, is as if an infinitely heavy needle had pierced the sheet, creating a bottomless drain. Near this drain, there is a boundary, an invisible frontier called the event horizon. Anything that crosses this threshold, a dust particle, a planet, a star, even a ray of light, is inevitably dragged toward the central singularity and is lost forever from the observable universe. We cannot see them directly, as they emit no light of their own. They are the embodiment of absolute darkness. We can only infer their presence by the effects they have on their surroundings, by the stars that orbit frantically around them, by the light from distant objects that bends as it passes near them, or by the agonizing scream of matter being torn apart and superheated just before being devoured. But not all black holes are the same. Like the creatures of an ecosystem, they exist in an astonishing variety of sizes and scales, a hierarchy of darkness that defines the structure of the universe. At the base of this pyramid are the stellar mass black holes. They are the most common, the citizens of the kingdom of night. They are born from the death of the most massive stars. When a star more than 20 times the mass of our Sun exhausts its nuclear fuel, it can no longer support its own weight. Its core implodes in a fraction of a second, collapsing to an infinite density, while its outer layers are violently ejected into space, in one of the universe's most spectacular explosions, a supernova. What remains after the fire and fury is a stellar corpse, a black hole with a mass between 3 and a few tens of times that of our Sun. They are relatively small in cosmic terms, with event horizons of just a few tens of kilometers in diameter. Our galaxy, the Milky Way, is littered with them, silent monuments to stars that lived fast and died spectacularly. Ascending the scale, we find a much more mysterious and elusive class of objects, intermediate mass black holes. For decades, they were the missing link of cosmology. Astronomers found small stellar black holes and the giants at the centers of galaxies, but almost none in the intermediate range, which goes from 100 to several 100,000 solar masses. Now, evidence suggests that these elusive objects reside in the hearts of globular clusters, ancient and dense agglomerations of stars that orbit our galaxy. They are thought to form from the merger of multiple stellar black holes or from runaway stellar collisions in the crowded center of these clusters. They are important because they could be the seeds from which the true giants, the titans that rule galaxies, grow. They are the princes of the kingdom, halfway to becoming kings. And at the top of the hierarchy, we knew, sit the supermassive black holes. These are the monarchs, with masses ranging from millions to several billions of times that of our Sun. They do not form from a single star, but grow over eons at the gravitational center of galaxies. They are the cosmic anchors, the dark hearts around which cities of billions of stars revolve. Our own Milky Way has one. It is called Sagittarius A star, and it has a mass of about 4 million suns. Fortunately for us, it is a relatively calm and sleeping giant. But in other galaxies, these kings are wide awake. A famous example is the black hole at the center of the galaxy, Messier 87, the first to be directly photographed by the Event Horizon Telescope. With a mass of 6.5 billion suns, it is a true leviathan, actively devouring matter and launching a jet of high-energy particles that extends for thousands of light years. For a long time, we thought these were the ultimate rulers of the universe. Giants like M87 seem to represent the upper limit of what was possible. But the universe is stranger than we can suppose. What if there were another gradation of darkness? A class of objects so massive that it would make a black hole of only 6 billion solar masses seem modest. This brings us to the most extreme category, the class of primordial titans, the gods of the early cosmos. The ultramassive black holes, objects that exceed 10 billion solar masses, they are not simply kings of a galaxy. They are anomalies that challenge our theories of structure formation. And it is in this category, on the highest rung of known existence, where our destination for tonight resides, an object that is not just ultramassive, but redefines the term. For the vast majority of human history, our understanding of the universe was dictated by a single source of information: visible light. We contemplated the cosmos through the narrow window of the electromagnetic spectrum to which our eyes are sensitive. Telescopes, even the largest and most powerful, were simply an extension of this vision. Giant glass eyes designed to gather more of that same ancient, silent light. But in the mid-20th century, a quiet revolution began to brew. Scientists developed a new way of seeing, one that did not depend on optics, but on electronics. They built telescopes that were not tubes with lenses, but enormous metal antennas, gigantic dishes aimed at the sky, not to see, but to listen. The era of radio astronomy was born. For the first time, we could tune into the universe and hear the invisible hiss of cosmic static, the faint radio emissions from cold, distant, and until then unknown objects. A new window to the cosmos was opened, and what astronomers found on the other side would forever change our understanding of the universe. As these new electronic ears scanned the firmament, they began to catalog thousands of new radio sources. Many of them were understandable. They could match a powerful radio emission with the shattered remnants of a supernova, or with the structure of a distant galaxy. But soon, a type of object emerged that made no sense at all. They were incredibly powerful radio sources, beacons that screened in the radio spectrum with tremendous force. However, when astronomers pointed their traditional optical telescopes to those exact coordinates, expecting to find a large galaxy or a spectacular nebula, they found nothing of the sort. Instead, at the center of this immense radio storm, they saw only a single point of light. A faint, bluish, solitary dot, indistinguishable from an ordinary, unremarkable star within our own Milky Way. This presented a deep and frustrating paradox. Normal stars, like our Sun, are relatively quiet objects in the radio spectrum. They do not produce the energy needed to generate such powerful emissions. What, then, were these strange objects? Were they a new type of star within our galaxy with unknown physics? Or were they something else entirely? Scientists gave them a descriptive name based on their appearance: quasi-stellar radio source. A cumbersome name that was soon shortened to the term we use today, quasar. For years, these enigmatic points of light remained one of the greatest mysteries in astronomy. They were the false stars of the sky, radio beacons disguised as mundane objects, hiding a secret of unimaginable energy. The key to unlocking this secret would come with the study of one of the brightest quasars in the sky, an object in the constellation of Virgo, known by its catalog number, 3C273. In the year 1963, a Dutch astronomer named Martin Schmidt, working at the legendary Palomar Observatory in California, decided to try to solve the enigma once and for all. He used the powerful 200-inch Hale telescope to capture not just an image of 3C273, but its spectrum. A spectrum is the fingerprint of light. By passing an object's light through a prism, it is broken down into its constituent colors, like a rainbow. But embedded in this rainbow are a series of dark or bright lines. These lines are created by the chemical elements within the object, and their pattern is unique to each element. They are a cosmic barcode that tells us what an object is made of. Schmidt observed the spectrum of 3C273 and was completely bewildered. The pattern of lines he saw did not correspond to that of any known element. It was cosmic gibberish, a code he could not decipher. Night after night, Schmidt sat with the data, perplexed. The lines simply made no sense. But then, in a moment of genius, he considered a radical possibility. What if the pattern of lines was familiar, but was disguised? He realized that 4 of the most prominent lines seemed to have a spacing similar to that of the Balmer series of hydrogen, the most common element in the universe. But they were in the wrong place in the spectrum. They were massively shifted toward the red end. This phenomenon, known as redshift, is the light equivalent of the Doppler effect in sound. Just as an ambulance siren sounds lower in pitch as it moves away, the light from an object moving away from us is stretched, and its wavelengths shift toward the red. Schmidt calculated the magnitude of this redshift, and the result was astonishing. It was 16%. For the light of hydrogen to be shifted that much, 3C273 had to be moving away from us at a speed of 47,000 kilometers per second. According to Hubble's law, which states that the speed at which a galaxy recedes is proportional to its distance, this breakneck speed implied a mind-boggling distance. 3C273 was not a faint star in our galaxy. It was an object located more than 2 billion light-years from Earth, in the depths of intergalactic space. This revelation solved one mystery, but created another, even larger and infinitely more profound. If this point of light was 2 billion light-years away, and yet we could still see and photograph it from Earth, it had to be shining with a luminosity that defied all known physics. The calculations were simple, but their implications were devastating. To be visible from that distance, 3C273 had to be brighter than hundreds of galaxies the size of the Milky Way combined. And all that energy, the equivalent of trillions of stars, was coming from a region of space that, due to its rapid variations in brightness, could not be much larger than our own solar system. What kind of engine could generate such an amount of energy in such a small volume? It was a problem that seemed to break the laws of physics. But false stars had revealed their true nature. They were not stars at all. They were the incredibly active nuclei of young, distant galaxies, beacons shining across the cosmos, allowing us to glimpse an era when the universe was a much more violent and energetic place. The door to a new universe of monsters had been opened. The discovery of quasars left the scientific community with a question that seemed to have no answer. What kind of cosmic engine could generate the energy of trillions of stars in a region of space barely larger than our solar system? The first, most obvious idea was that perhaps it was an unprecedented concentration of stars, an agglomeration of billions of suns packed into an incredibly dense cluster. But this idea quickly crumbled in the face of the laws of physics. Such a massive concentration of stars would instantly collapse under its own gravity, forming a single supermassive object. Furthermore, the rapid fluctuation in the brightness of quasars indicated that the light source had to be relatively small. If an object is 1 light-year in diameter, it cannot change its total brightness faster than in the span of 1 year, the time it takes for light to cross it. Quasars flickered on scales of weeks, days, or even hours, implying an origin of an astonishingly compact size. The answer, therefore, could not be in the stars. It had to be something much more exotic, something we had already introduced into our map of the cosmos, the supermassive black hole. Herein lies the central paradox that baffled the early researchers. How is it possible that the darkest object in the universe, an entity whose very definition is the absence of light, is responsible for the most luminous phenomenon? The answer is one of the most beautiful and violent ironies of nature. The light from a quasar does not come from inside the black hole. It comes from the threshold, from the point of no return, from the final banquet of matter before it disappears forever. Imagine a supermassive black hole with a mass of millions or billions of suns lurking in the heart of a young galaxy. These primordial galaxies were chaotic, dense, and gas-rich places, a cosmic feast for a gravitational predator. Immense clouds of hydrogen, streams of dust, and even entire stars, in their chaotic orbits around the galactic center, could stray too close to the sleeping giant. Once caught by its immense gravity, their fate was sealed, but they did not fall in directly. Like water swirling before going down a drain, the matter captured by the black hole begins to spin. Its own angular momentum, the inertia of its motion, forces it to flatten out and form a vast, rotating structure, an accretion disk. This is not a simple ring of debris. It is a colossal structure, a cosmic vortex that can extend for trillions of kilometers. It is here in this disk that all hell breaks loose. The matter in the outer part of the disk moves at considerable orbital speeds. But as it gets closer to the black hole, gravity accelerates it to significant fractions of the speed of light. Gas clouds moving at hundreds of thousands of kilometers per second collide, compress, and rub against each other. This titanic friction, combined with the immense gravitational compression, heats the material to temperatures that dwarf those of our sun's core. The gas is heated to millions, even billions of degrees, until it becomes an incandescent plasma that glows with an intensity that defies description. This is the engine of the quasar. It is the cosmic banquet, where the food is heated to incandescence before being devoured. It is the scream of light from matter in its final moment. And the show doesn't end there. Not all the matter in the accretion disk is destined to fall into the black hole. The system's magnetic field, twisted into a frantic knot by the rapid rotation of the disk and the black hole itself, acts as a cosmic particle accelerator. This magnetic field traps a portion of the superheated particles from the inner disk and, instead of allowing them to fall, channels them and launches them outward in two colossal beams emanating from the black hole's poles. These are the relativistic jets. These jets of plasma travel at nearly the speed of light and can extend far beyond the confines of the host galaxy, over millions of light years. They are like the headlights of this cosmic engine, injecting energy into intergalactic space and leaving a visible signature in the radio spectrum, solving the original mystery of the radio stars. This model of a feasting supermassive black hole perfectly explains all the strange properties of quasars. It explains the immense energy production, which comes from the conversion of mass into radiation with an efficiency that dwarfs nuclear fusion. It explains the small size of the source, as all the light comes from the compact region immediately surrounding the event horizon. And it explains why we see them primarily in the distant and therefore early universe. Young galaxies were rich in the gas that fueled these banquets. The mature galaxies of today, like ours, have largely depleted that central gas supply. Their supermassive black holes are, for the most part, dormant and on a diet, sleeping giants waiting for a meal that rarely comes. The mystery of the false stars was solved. They were the echoes of a bygone era, an age of voracious giants and cosmic banquets that illuminated the infant universe. And armed with this knowledge, astronomers were now prepared to identify the greatest of them all. With the revolutionary understanding of quasars, astronomers in the 1960s embarked on a new and strange hunt. They were no longer just searching for planets, stars, or galaxies. They were searching for imposters. Their prey were those blue, seemingly innocent points of light hiding in the depths of the cosmos, points that at first glance look like nearby stars, but, upon closer analysis, revealed themselves as the most powerful beacons in the universe. The Milky Way, our own galactic home, had become a sort of veil, a curtain of local stars behind which these monsters from a bygone era were hiding. To find them, astronomers needed maps, they needed catalogs, and paradoxically, the story of the greatest of all these giants did not begin in a great observatory with a plan to decipher the early universe, but in a much more modest survey with a completely different goal. Our journey takes us to Mexico in the year 1957. On a plateau in the state of Puebla stands the Tonantzintla National Astronomical Observatory. In that era before the digital age, astronomy was an art of patience, chemistry, and glass. Astronomers did not sit in front of computer screens, but spent long nights in the cold, guiding their telescopes to capture the faint light of the stars on large, delicate glass photographic plates. After hours of exposure, these plates were taken to a darkroom where the smell of developing chemicals filled the air as the latent images of the cosmos slowly emerged into life. One of the observatory's key projects at the time was a survey of the North Galactic Pole. They were photographing a region of the sky that lies far above the main plane of the Milky Way, an area where the veil of stars and dust from our galaxy is thinnest, allowing a clearer view into deep space. Their goal was modest. They were looking for faint blue stars, white dwarfs, and other peculiar objects within the confines of our own galaxy. On one of these glass plates, captured by the observatory's powerful Schmidt camera, appeared a faint, unremarkable blue port of light. It met all the criteria of the search. The astronomers measured it, noted its position and brightness, and assigned it a catalog number. It was the 618th object reported in their survey. Its official name was therefore Tonantzintla 618, and that was it. For more than a decade, TON 618 was nothing more than that, an obscure entry in an astronomical catalog, a footnote in a study of blue stars, classified as a probable subdwarf star. No one suspected its true nature. It was perfectly camouflaged, a cosmic wolf in the skin of an ordinary star, hiding in plain sight. The disguise began to unravel in the early 1970s. Radio astronomy had matured, and astronomers were busy cross-referencing their radio catalogs with optical catalogs. In Italy, radio astronomers using the Northern Cross radio telescope near Bologna detected a radio source in the sky. Upon checking the coordinates, they discovered it perfectly matched the position of that seemingly boring blue star, TON 618. This immediately set off alarms in the astronomical community, as they already knew from the case of 3C273. Normal blue stars do not emit powerful radio waves. This coincidence was the hallmark, the fingerprint of a quasar. The suspicion that TON 618 was much more than it appeared spread rapidly. The time had come to rip off its mask. A team of astronomers aimed a spectrograph at the object. Just as Martin Schmidt had a decade earlier, they broke down the light of TON 618 into its rainbow spectrum, searching for the chemical barcode within. What they found not only confirmed their suspicions, but surpassed them in a way they could barely comprehend. The spectrum showed the familiar lines of hydrogen, but they were shifted to the red by a monumental amount. The redshift of TON 618 was 2.219. This number, though abstract, was a dagger to the heart of its identity as a star. It implied that the object was moving away from us at a speed that was more than 80% of the speed of light, which in turn meant it was at a distance of more than 10 billion light-years. It belonged to an era when the universe was less than a third of its current age. But there was something else in its spectrum, a detail that set it apart. The emission lines were not sharp and thin. They were incredibly broad and fuzzy. Astronomers knew what this meant. The lines are broadened by the Doppler effect, of the source emitting the light. In this case, it was massive gas clouds orbiting the central object at dizzying speeds, up to 7,000 kilometers per second. Such a devilish speed could only be maintained by a gravitational force of almost inconceivable magnitude. The width of those lines was a power meter, a direct signature of the mass of the central engine. The calculations were preliminary, but the figures they yielded were insane. The luminosity needed to be visible at that distance was 140 trillion suns, and the mass required to hold those gas clouds at that speed was in the billions of solar masses. TON 618 was not just another quasar. It was the most luminous quasar and potentially the most massive black hole ever detected. The humble blue star from the Tenancintla catalog had been unmasked, revealing itself not just as a wolf, but as the titan that reigned over all others. The revelation that TON 618 was a quasar more than 10 billion light-years away was only the first step. Its light spectrum held a promise, a tantalizing clue of an almost inconceivable mass. The broad, fuzzy hydrogen emission lines screamed that the gas in its vicinity was moving at speeds of thousands of kilometers per second, a frantic waltz dictated by a gravitational master of unimaginable power. But a clue, however strong, is not a measurement. Scientists needed a number. They needed to put the monster on a scale, and this presented a challenge that bordered on the impossible. A black hole is, by definition, invisible. It cannot be observed directly, and at such a colossal distance, it is absolutely impossible to see the individual stars orbiting it, which is the method used to weigh our local black hole, Sagittarius A. Astronomers needed a different technique, a method of extraordinary subtlety and ingenuity, capable of operating across billions of light-years. They needed to learn how to measure the echo of the abyss. The technique they developed is called reverberation mapping, and it is one of the most elegant tools in modern astrophysics. To understand it, imagine you are in the middle of a vast canyon on the darkest night, and you want to know how far away the surrounding walls are. You can't see them, but you can use sound. You clap your hands loudly, a sharp, sudden pulse of sound. You hear the sound of your own clap almost instantly. Then, a few seconds later, you hear an echo, the sound of that clap bouncing off the distant canyon walls. If you carefully measure the time it takes for the echo to return, and you know the speed of sound, you can accurately calculate the distance to those invisible walls. Reverberation mapping applies this exact same principle, but on a cosmic scale, and uses light instead of sound. At the heart of TON 618, the accretion disk, that vortex of superheated matter surrounding the black hole, does not shine with a perfectly constant light. It is a chaotic and turbulent system, and its brightness flickers and fluctuates unpredictably. Sometimes it's a little brighter, sometimes a little dimmer. These flickers, these variations in light, are the astronomer's clap. This pulse of light travels outward in all directions at the speed of light, orbiting far beyond the accretion disk, but still well within the black hole's gravitational well, is a vast, diffuse region of hydrogen gas clouds. It is a kind of turbulent atmosphere surrounding the central engine, and it is known as the broad line region, because it is precisely here that the broad emission lines that astronomers see in the spectrum originate. When the clap of light from the accretion disk hits these clouds, it energizes them, causing them to glow more intensely, like a fluorescent light bulb turning on. This flash from the gas clouds is the echo. The astronomer's job, a task of incredible patience, is to observe TON 618 for months, even years. They continuously measure the brightness of the accretion disk, the clap, and, simultaneously, measure the brightness of the hydrogen emission lines, the echo. Inevitably, they find a correlation. An increase in the disk's brightness is followed some time later by an increase in the emission line's brightness. This time later is the echo delay. It is the time it took for light to travel from the central disk to the broad line region. By measuring this delay, which in the case of TON 618 is hundreds of days, astronomers can directly calculate the average distance between the black hole and the gas clouds orbiting it. They have measured the radius of the canyon. Now they have one half of the equation. The other half they already had hidden in the spectrum. The width of the emission lines, as we've already seen, tells them the speed at which those gas clouds are moving. A broader line means the gas is moving faster. With these two pieces of information, the distance of the clouds from the center, measured by the echo delay, and the speed at which they orbit, measured by the width of the lines, astronomers can apply the laws of orbital physics to calculate the mass of the central object that is dictating that motion. It is a calculation of astonishing beauty and power. They are using light as a tape measure and a speedometer to weigh an invisible object that is more than halfway across the observable universe. When they applied this technique to TON 618, the result they obtained solidified its status as the king of giants. The number that emerged from the echoes of light was 66 billion. 66 billion times the mass of our sun. It is a figure that shatters any intuitive scale. The black hole in our galaxy has 4 million solar masses. The famous giant of N87 has 6.5 billion. TON 618 is not just a little bigger. It is 10 times more massive than one of the largest black holes we knew. It is a beast of a completely different category. The wolf in star's clothing had not only been unmasked. Now, thanks to the echo of its own violent heart, it had been put on the scale. And the weight it registered broke the scale. 66 billion. The number itself is a ghost in our minds, a mathematical abstraction so vast that it lacks any real anchor in our experience. 66 billion times the mass of our sun. To give this figure real meaning, to feel its gravitational weight, we must translate it from a measure of mass to a measure of space. To a physical dimension, we must try to visualize the anatomy of this titan. The main component of a black hole, its only defining feature visible to the outside universe, is its event horizon. It is not a solid surface, nor a membrane. It is a boundary, an immaterial but absolute threshold. It is the point in space where the escape velocity, the speed needed to break free from the black hole's gravitational pull, becomes equal to the speed of light. Since nothing in the universe can travel faster than light, anything that crosses this boundary is irrevocably lost. It is the edge of the abyss, and the size of this abyss, the radius of this event horizon, is directly proportional to the mass of the black hole. The more massive the monster, the bigger its cage. To begin building a mental image of the scale of TON 618, let's start with something we can comprehend. If our sun, with its single solar mass, were to collapse to form a black hole, its event horizon would have a radius of just 3 kilometers. You could place 3 of them side by side across the width of an average city. Now, let's take the supermassive black hole at the center of our own galaxy, Sagittarius A. With its mass of 4 million suns, its event horizon would expand to a radius of about 12 million kilometers, a considerable size, but still smaller than the orbit of the planet Mercury. It remains a structure we can visualize within the confines of our own solar system. Even the giant of the galaxy M87, with its 6.5 billion solar masses, has an event horizon that would extend far beyond the orbits of the rocky planets, but would barely reach the orbit of Pluto. It is still, in a way, a neighbor of our solar system in terms of scale. Now let's take the mass of TON 618 and calculate the size of its cage. With 66 billion solar masses, Its event horizon expands to a radius of approximately 1,300 astronomical units, 1,300 times the distance between the Earth and the Sun. This number, like its mass, needs translation. Let's take a mental journey from the center of our own solar system outward to feel the true magnitude of this dimension. We start from the Sun. At 1 astronomical unit, we cross Earth's orbit. At 5 units, we pass Jupiter. At 9.5, we greet Saturn with its rings. We continue traveling, crossing the orbits of Uranus and Neptune, the outermost planet, which is about 30 astronomical units from the Sun. At this point, we are at the edge of the planetary solar system. The Voyager probes, the fastest travelers we have ever launched, took decades to reach this frontier. But we haven't even come close to the edge of TON 618. We continue, crossing the Kuiper Belt, home to Pluto and other icy worlds, which extends to about 50 astronomical units. We press on into local interstellar space, passing the heliopause, the boundary where our sun's wind finally gives way to the interstellar medium, at about 100 astronomical units. We have traveled farther than any man-made object, and we still haven't covered a tenth of the radius of TON 618's event horizon. To reach the edge of this black hole, we would have to continue traveling until we reached a distance of 1,300 astronomical units. It's a scale that annihilates our own. Our entire solar system, with all its planets, asteroid belts, and dwarf worlds out to Neptune, would fit more than 40 times, side by side, within the diameter of TON 618's darkness. Imagine for a moment what this means. Not a sphere of rock or gas, but a sphere of pure and perfect blackness, a region of space-time from which not even light escapes, and which is thousands of times larger than our own planet's neighborhood. It is so immense that, unlike with small black holes, the tidal forces at its event horizon are relatively gentle. A hypothetical traveler crossing this boundary would not be instantly torn apart by spaghettification. They would simply float across the threshold without immediate drama, only to realize, too late, that the exit has vanished forever. Physics tells us that a black hole is an incredibly simple object. It is defined solely by its mass, its spin, and its electric charge. All the complexity of the billions of stars and gas clouds it has devoured over the eons is erased, leaving only these 3 fundamental properties. The event horizon of TON 618 is the manifestation of this terrifying simplicity, a perfect, featureless sphere, a mathematical surface that encloses the lost history of a significant portion of the early universe. We have explored the anatomy of this darkness. Now, we must turn our attention to the furious and paradoxical light that is generated at the very edge of this cosmic prison. We have just traced the dimensions of a blackness so vast that our own solar system is but a speck of dust in comparison. We have visualized a boundary, an event horizon, that defines a prison for light of an almost inconceivable size. And yet, from the very edge of this absolute darkness emanates the most violent and sustained light we have ever observed in the universe. This is the great engine, the cosmic forge that astronomers call a quasar. Now, we will delve into the anatomy of this structure of light, a beacon that shines across the eons, fueled by the abyss it seeks to hide. The source of this energy is not a mystery of exotic physics, but the result of the most fundamental force of all, gravity, magnified to a monstrous scale. The engine of TON 618 is its accretion disk. Imagine rivers of gas and dust, interstellar clouds larger than 1,000 solar systems, and even entire stars being drawn from the far reaches of the host galaxy toward the gravitational well of the central black hole. As this matter falls, it does not plummet directly, but swirls, forming a flattened, rotating disk. a colossal structure of superheated plasma that dwarfs our solar system. It is in this disk that the energy is unleashed. The matter composing it spins at speeds approaching that of light. And the friction between the different layers of this cosmic vortex is so immense, the gravitational compression so brutal, that the gas heats up to millions of degrees. The result of this gravitational banquet is an emission of light, of radiation, of a magnitude that our minds can barely process. The luminosity of TON 618 has been calculated to be 140 trillion times that of our Sun. 140 trillion. It is, once again, a number that floats unanchored in our imagination. Let's try to give it some perspective. Our galaxy, the Milky Way, is a vast and bright place. It contains between 200 and 400 billion stars, each a sun, shining together to create the majestic band of light we see on a dark night. The combined light of all those billions of stars is the total luminosity of our galaxy. The quasar of TON 618, by itself, shines with an intensity more than 100 times greater than that of our entire Milky Way. Imagine a city with 200 billion light bulbs on, and then, in the center, place a single bulb that is 100 times brighter than the entire city combined. That bulb is the quasar of TON 618. The city, almost invisible beside it, is its host galaxy. Its energy efficiency is astounding. Our Sun, like all stars, generates energy through nuclear fusion, converting hydrogen into helium. This process, though powerful, is relatively inefficient, converting only about 0.7% of the mass into energy. The accretion disk of a black hole like TON 618 is the most efficient energy conversion engine that nature allows. Depending on the black hole's rotation, it can convert between 10 and 40% of the mass of falling matter directly into pure radiation. It is a fire of almost perfect efficiency, extracting an unparalleled amount of energy from everything it devours. The light it produces is not just the visible light our eyes can perceive. The immense temperature of the accretion disk means it radiates energy across the entire electromagnetic spectrum. In the innermost, hottest regions, closer to the event horizon, it emits a furious storm of X-rays and high-energy ultraviolet radiation. A little further out, in regions still hotter than any star, it shines with an intense blue-white visible light. And in its vast outer regions, it emits infrared radiation and the powerful radio waves that led to its initial discovery. It is a total light source, a beacon that floods its surroundings with radiation of every imaginable wavelength. This incredible energy output has a profound effect on its environment. The intense radiation emanating from the quasar exerts physical pressure, creating a cosmic wind of unimaginable force. This wind blows through the host galaxy, heating and sweeping away the cold gas clouds that would otherwise have condensed to form new stars. This phenomenon, known as quasar feedback, means that the quasar itself is sterilizing its own galaxy. In its act of shining with such incredible intensity, it is shutting down the engine of stellar creation around it. It is a force both creative and destructive, a flower of light so bright that it withers the garden in which it grows. We have explored the anatomy of darkness, and now the anatomy of its light, a light born from gravity, fed by condemned matter, and shining with the force of 100 galaxies from the edge of the abyss. Every supermassive black hole, no matter how large, needs a home. They do not exist in isolation, floating in the intergalactic void, but reside in the gravitational heart of a much larger structure, a galaxy. They are the engines, the nuclei, the anchors around which billions of stars, gas clouds, and planetary systems orbit. Our Milky Way has Sagittarius A star. The Andromeda Galaxy has its own, Messier 87 is famous for its own. Therefore, it is an astrophysical certainty that TON 618, the king of them all, must reside at the center of its own host galaxy. However, when astronomers point their most powerful telescopes to its location in the sky, they are met with one of the strangest and most frustrating paradoxes in cosmology. They search for a vast city of stars, but all they see is a single blinding light. The monster's heart shines with such unimaginable ferocity that it has rendered its own body invisible. The galaxy of TON 618 is lost in its own light. To understand this extraordinary situation, let's turn to a terrestrial analogy. Imagine you are flying over a vast metropolis at night. Below you, you see a network of light stretching for hundreds of kilometers, the glow of streetlights, the windows of buildings, the headlights of cars. You can distinguish neighborhoods, main avenues, dark parks. You see the structure of the city. Now, imagine that in the central square of that city, a single light source is turned on. A spotlight of inconceivable power that is 100 times brighter than all the other lights in the city combined. As you move away, the delicate network of city lights begins to fade, completely drowned out by the overwhelming glare of that single point. Soon, you can no longer distinguish the neighborhoods or the avenues. The entire city disappears, swallowed by the veil of light from its own center. All you see is the spotlight. This is precisely the situation astronomers face when observing TON 618. The quasar, with its brightness of 140 trillion suns, is that spotlight. The host galaxy, with its billions of stars, is the city drowned in its glare. This phenomenon presents an immense technical challenge. When a telescope like the Hubble or the James Webb observes TON 618, the light from the quasar, which is a point source, is so intense that it saturates the camera's detectors. The brightness overflows, creating diffraction spikes and artifacts that contaminate the entire image. The light from the host galaxy, which is thousands of times fainter and is diffuse, spread across the entire region, is completely buried under this torrent of radiation. It is like trying to hear the whisper of a falling leaf in the middle of a rock concert. The whisper is there, but the main signal completely drowns it out. For decades, astronomers could only infer the existence of the host galaxy. They knew it had to be there, but they couldn't see it. Still, they could deduce some of its properties. To have fueled the growth of a 66 billion solar mass black hole so early in the universe's history, this galaxy could not be ordinary. It had to be one of the most massive and gas-rich galaxies of its time. It was likely the result of multiple violent mergers with other galaxies. These cosmic collisions are incredibly effective at disturbing the orbits of gas clouds and funneling them toward the galactic center, providing the torrent of fuel needed to ignite such a monstrous quasar. Therefore, the image astronomers had in mind was not that of an orderly and elegant spiral galaxy like our Milky Way, but of a chaotic and disturbed structure, a cosmic battlefield where a giant was being forged. Only in recent years, with the advent of more advanced observation technologies, have we begun to glimpse the hidden beast. Using incredibly sophisticated image processing techniques, astronomers can carefully model the light from the quasar's bright point and digitally subtract it from the total image. It is a procedure of extreme delicacy, the digital equivalent of covering that blinding spotlight with an incredibly precise finger to see the faint light of the city behind it. What emerges from this process is a ghost, a faint, reddish, diffuse smudge of light, extending around the point where the quasar's glare used to be. That smudge is the host galaxy of TON 618. It is the first time we have seen the Titan's home. The details are sparse, but the image confirms suspicions. It appears to be a giant elliptical galaxy, one of the most luminous known in the early universe, surrounded by a halo of smaller galaxies that are likely in the process of being cannibalized. We see a city of stars, but it is a city condemned by its own glorious center. The same radiation that makes it so remarkable is sweeping the cold gas from its interior, shutting down the birth of new stars and ensuring that once the quasar fades, the galaxy will become a graveyard of old red stars. It is a creature devouring itself from the inside out, a beacon so bright it has burned down its own harbor. The lost galaxy has been found, but what we have discovered is a shadow, an echo of a city, whose light reaches us more than 10 billion years later, reminding us that in the early universe, existence itself was an act of unimaginable violence and beauty. All the light we see is an echo of the past. This is the most fundamental and poetic principle of astronomy. The speed of light, though the fastest in the universe, is finite. This means that every ray of light that reaches our eyes or our telescopes has spent time traveling to reach us. Therefore, every telescope is not just an instrument for seeing through space, but also a time machine. When we look at the sun, we do not see it as it is now, but as it was 8 minutes ago, the time it takes for its light to cross the 150 million kilometers that separate us. We see Jupiter as it was almost an hour ago. The nearest star, Proxima Centauri, we see as it was more than 4 years ago. The Andromeda Galaxy, our great neighbor, shows us its light as it was 2.5 million years ago, when the first ancestors of the human genus walked the Earth. Every act of astronomical observation is an act of cosmic archaeology. Now, let's apply this principle to TON 618. Its light has traveled for more than 10 billion years to reach us. This is not a simple figure. It is an abyss of time so deep that it defies our ability to contextualize. When the photons of light that we detect in our telescopes today began their journey from the accretion disk of TON 618, our solar system did not exist. There was no sun, no Earth, no planets. The gas and dust that would eventually condense to form our world were still scattered throughout the galaxy, billions of years away from coming together. The light from TON 618 had already been traveling through a dark and expanding universe for 6 billion years before our planet was formed. Imagine the odyssey of one of those photons. It was born in a storm of unimaginable violence, in a plasma hotter than the core of a star, at the edge of an ultramassive black hole. It was launched into space and began its solitary journey across the cosmos. It saw the formation of the first great galaxies, passed through vast nebulae where new generations of stars were born, and dodged the tendrils of the cosmic web of dark matter. Meanwhile, in a quiet corner of an unnamed spiral galaxy, a small yellow star came to life, and around it, a disk of debris coalesced to form a small blue and white planet. Life arose on that planet. It evolved, it diversified, and billions of years later, one of the species on that planet built a telescope, pointed it at a blue point of light in the constellation of Canes Venatici, and at that precise moment, the 10 billion year journey of that solitary photon came to an end, delivering its message from the past. What we see when we observe TON 618 is not a contemporary object. It is a fossil of light. It is a window into a specific and crucial era in the history of the universe, a period that cosmologists sometimes call the cosmic noon or the quasar era. This was the turbulent adolescence of the universe, approximately 2 to 4 billion years after the Big Bang. The universe was smaller, denser, and much more chaotic. Galaxies were in the midst of formation, colliding and merging with a much greater frequency than today. And, most importantly, these young galaxies were incredibly rich in gas, the primordial fuel for star formation, and, as we have seen, for feeding the banquets of supermassive black holes. In that era, quasars like TON 618 were common, beacons illuminating the cosmos everywhere. 10618 is not a rarity in its original context. It is a perfectly preserved specimen of the class of giants that populated the universe in its youth. This fossil of light is not just a curiosity. It is a tool of incalculable value. By studying the light of 10618, astronomers can analyze the chemical composition of the early universe. But perhaps most astonishingly, the quasar's light acts as a background flashlight. As it travels toward us, it passes through invisible clouds of hydrogen gas that float in the vast space between galaxies. Each of these clouds absorbs a small, specific portion of the quasar's light, leaving a mark, a dark line, in its spectrum. By analyzing the pattern of these thousands of absorption lines, astronomers can map the invisible structure of the cosmic web in the past, revealing how matter was distributed in the early universe. And this brings us to the deepest and most dizzying question of all. If what we see is the past, what is 10618 like in the present? The quasar we observe, that beacon of 140 trillion suns, went out billions of years ago. Its cosmic banquet ended when it consumed all the accessible gas around it, or when the pressure of its own radiation swept away the rest of the fuel. The object that exists now at that distant coordinate in space is, in all likelihood, a silent and dark ultramassive black hole, the dormant anchor of a now mature and quiet galaxy. We are observing the ghost of a king, the echo of a roar that died out eons ago. We can never know what it is like in our present. The light it emits today will not reach this corner of the Milky Way for another 10 billion years. What we observe is not the beast, but its memory, a relic of light that tells us the story of a young and savage universe. The existence of 10618, as we see it in that cosmic dawn more than 10 billion years ago, is not just a marvel. It is a profound paradox. It is a piece of evidence that does not quite fit into our most elegant theories about how the universe works. Cosmologists face a problem of time. They have observed the monster, but they do not understand how it could have been assembled so quickly. It is like finding a 100-story skyscraper on a construction site that has only been active for a week. The fundamental question that 10618 poses is this: what is the recipe for creating a 66 billion solar mass black hole in less than 3 billion years from the beginning of the universe? The answer is that our standard recipe, the one that works so well for smaller supermassive black holes, is simply not enough. Our conventional model for the growth of supermassive black holes is a gradual, almost patient process. It starts with a seed. This seed can be a stellar mass black hole, the remnant of one of the first massive stars in the universe, or perhaps a slightly larger black hole formed from the collapse of a dense star cluster. From there, the seed grows in two ways: by eating and by merging. It eats by slowly attracting the gas and dust that swirl in the center of its host galaxy, and it merges with other black holes when its galaxy collides and joins with others. However, the act of eating has a natural speed limit, a cosmic safety brake known as the Eddington limit. As the black hole feeds, its accretion disk heats up and shines. If it feeds too quickly, the brightness becomes so intense that the radiation pressure itself acts as a wind that pushes and disperses the gas trying to fall in. The black hole, in its greed, chokes off its own food source. This limit imposes a maximum growth rate, and therein lies the problem. Even if we take a black hole seed and feed it at the maximum theoretical rate without stopping for over 1 billion years, the mathematical models struggle to reach the mass of 10618. There simply isn't enough time. The standard recipe produces supermassive kings, but not ultramassive titans. To create 10618, the universe needed a shortcut. It needed a different and much more violent recipe. One of the most promising theories for this shortcut is that of direct collapse black holes. This idea posits that, Under the unique conditions of the early universe, nature found a way to skip the intermediate steps. In that era, there existed immense clouds of primordial gas, composed almost entirely of pure hydrogen and helium. Normally, such a massive gas cloud would cool and fragment into thousands of smaller points, giving birth to a star cluster. But theorists propose a special scenario. If one of these primordial clouds were irradiated by the intense ultraviolet light of a nearby young galaxy, this external radiation could have kept the gas hot, acting like a cosmic oven that prevented its fragmentation. Without the ability to break into smaller pieces, the entire cloud, with a mass of hundreds of thousands of suns, would have become catastrophically unstable and collapsed all at once, not into a star, but directly into a black hole. This process would create a heavy seed, a black hole born not with 10, but with 100,000 solar masses. It is the difference between building a castle brick by brick and starting with a prefabricated fortress. Starting from such a massive base, the path to reaching the 66 billion solar masses of TON 618 becomes much more feasible within the available cosmic time. Another possibility is that the rules of the cosmic banquet do not always apply. Perhaps, under certain conditions, a black hole can break the Eddington limit. If instead of a steady, uniform flow of gas, the black hole is fed by cold, dense, clumpy streams of gas, these streams could be massive and fast enough that radiation pressure cannot stop them. The gas would fall into the black hole like an avalanche, a forced feeding that normal physics could not prevent. This model of hyperaccretion, or superfeeding, would allow for periods of exponentially rapid growth, where the black hole increases its mass at an uncontrolled rate during brief but crucial epochs of its youth. Finally, there is the most speculative idea of all, primordial black holes. Unlike all others, these would not form from ordinary matter like stars or gas clouds. They would be relics of the very birth of the universe. In the first fraction of a second after the Big Bang, the universe was a place of extreme and fluctuating densities. It is theoretically possible that some of these ultra-dense regions did not expand, but collapsed directly into black holes of various sizes. If a sufficiently massive primordial black hole was formed in the Big Bang, it would have simply been waiting at the center of a forming galaxy, ready to begin its banquet. Which of these recipes is correct, or if it is a combination of all of them, remains one of the great unsolved mysteries of cosmology. TON 618 is not just an object of study, it is evidence of a crime against our conventional understanding. It is a corpus delicti that forces us to seek new explanations, to rewrite our cosmic recipe book to include chapters on the birth of monsters. It teaches us that the early universe may have had pathways to create giants that our current physics is only beginning to glimpse. The cosmic banquet that gives life to a quasar is the most energetic and luminous event in the universe, a storm of light and radiation that can outshine entire galaxies. But, like all storms, no matter how violent, it cannot last forever. The engine of a quasar, a supermassive or ultramassive black hole, is practically eternal, but its fuel is not. The dazzling light that defines a quasar is a transient phenomenon in the long life of a galaxy, a spectacularly violent phase of youth that must inevitably give way to a long and quiet maturity. The question, then, is not if a quasar turns off, but how. The giant must finally go to sleep, and it does so through two interconnected processes that ensure the feast comes to an end. The first and simplest mechanism is fuel exhaustion. The black hole at the center of a young galaxy is like an insatiable furnace in the middle of an infinite forest. At first, the fuel, in the form of vast and chaotic clouds of primordial gas, is everywhere. Mergers with other gas-rich galaxies act like cosmic lumberjacks, felling trees and endlessly throwing them into the fire. For millions or even hundreds of millions of years, the banquet continues. The black hole consumes an amount of matter equivalent to several suns per year, converting that mass into the pure radiation we see as a quasar. But the forest is not infinite. Over time, a significant portion of the gas in the central regions of the galaxy is consumed by the black hole. Another portion, perhaps the larger one, is used in a much more constructive way. It cools and condenses to form billions of new stars. Once the gas is locked up in a star, it is no longer available as fuel for the quasar. Slowly, over eons, the supply of accessible gas in the galactic center dwindles. The torrent of matter that fell into the accretion disk is reduced to a river, then a stream, and finally, a trickle. The accretion disk, deprived of new material, thins, cools. Its flickering light finally fades into darkness. The giant falls asleep simply because the food has run out. But there is a second, more dramatic and proactive mechanism. The quasar does not just passively turn off. It actively participates in its own extinction. As we saw, the light emitted by the accretion disk is so intense that it exerts physical pressure. This phenomenon, known as quasar feedback, acts as a galactic wind of unimaginable force. Imagine a cosmic hairdryer the size of a solar system. The intense radiation and particle jets emanating from the quasar blow outward, sweeping through the host galaxy. This wind expels the cold gas clouds from the central regions, launching them into the galactic halo or even into intergalactic space. In an act of ultimate self-sabotage, the quasar, at the height of its power, destroys its own supply line. It becomes so bright that it literally scares away the food. This process not only turns off the quasar, but also has a profound effect on the evolution of the entire galaxy, halting the formation of new stars and ensuring that, once the light goes out, the galaxy enters a phase of quiet retirement. And what is left afterward? What is a galaxy when its central beacon has been extinguished? What remains is a galaxy very much like our own. At its center, the ultramassive black hole, now invisible and silent, is still there. Its immense gravity still governing the orbits of billions of stars. It is a sleeping giant. The surrounding galaxy, now stripped of its star-forming gas, ceases to produce young hot blue stars. It becomes a red and dead galaxy, dominated by the softer, older light of its long-lived stars. This story, a violent and luminous youth, followed by a long and quiet maturity, is believed to be the biography of most large galaxies in the universe, including the Milky Way. Our own supermassive black hole, Sagittarius A, is a sleeping giant. Evidence suggests that in the distant past, billions of years ago, our own galaxy may have hosted a quasar. Astronomers have discovered two immense bubbles of hot gas that emit gamma rays and extend for 25,000 light-years above and below the plane of our galaxy. These structures, known as the Fermi bubbles, are interpreted as the ghostly echoes, the remnants of a massive energy eruption that occurred when our central black hole had its own great banquet. We live in the calm that follows our own galaxy's storm. A sleeping giant, however, can awaken. If a new supply of fuel presents itself, the banquet can begin anew. This usually occurs through a cataclysmic event, such as the collision and merger with another galaxy. In about 4.5 billion years, our Milky Way is destined to collide with our neighbor, the Andromeda Galaxy. This massive event will destabilize billions of stars and gas clouds, sending a new stream of fuel toward the newly merged supermassive black hole at the center of the new galaxy. It is very likely that this event will ignite a new quasar in our own cosmic backyard. The light from 10618 that we see is therefore that of a giant at its moment of maximum wakefulness. The current reality of that object, 10 billion years later is almost certainly that of a sleeping giant, waiting in the darkness. The cycle of cosmic life is one of furious banquets and profound silences. In the cosmos, as on Earth, there are hierarchies of power and scale. We have explored the nature of black holes, from stellar remnants to the giants that nest in galactic centers. But to truly understand the magnitude of TON 618, to feel its weight in the pantheon of cosmic monsters, we must take a comparative tour. We must visit a gallery of titans, a hall of fame of the most massive objects in the universe, to see exactly where our protagonist fits. This journey will show us that TON 618 is not just another member of this exclusive club. It is the solitary monarch who reigns from a throne so high that the other kings can barely glimpse its shadow. Let's begin our tour at home with the local champion, Sagittarius A star, the supermassive black hole at the heart of our own Milky Way. It is located about 27,000 light-years away, hidden behind dense clouds of dust and gas. After decades of patiently observing the stars that orbit around it, we have measured its mass with astonishing precision. Approximately 4 million times the mass of our Sun. It is an impressive figure, a gravitational anchor that governs the fate of our entire galaxy. Its event horizon, though vast, would fit inside the orbit of Mercury. It is a giant, yes, but as we will see, it is the giant of our own quiet neighborhood. It is our reference point, the unit of measure with which we will begin to build our scale of the incredible. Now let's take a small leap to the next step, to our large neighboring galaxy, Andromeda, about 2.5 million light-years away. At its center, which is larger and brighter than that of the Milky Way, resides a supermassive black hole considerably larger than ours. Measurements indicate that the mass of Andromeda's black hole is in the range of 100 to 200 million solar masses. It is a significant jump. This giant is tens of times more massive than Sagittarius A star, a testament to Andromeda's more violent history. A history filled with more galactic mergers and cosmic banquets. If Sagittarius A star is the king of our stellar city, Andromeda's is the emperor of a much larger neighboring empire. We are already beginning to see that in the cosmos there is always a bigger fish. But to find the true heavyweight champion of the nearby universe, we must travel much further. About 55 million light-years to the constellation of Virgo. There resides the giant elliptical galaxy Messier 87, and at its heart is the famous M87 star, the first and only black hole that humanity has managed to photograph directly. Its iconic image, a ring of bright light surrounding a circular shadow, has become the face of black holes around the world. It is a cosmic celebrity, and its fame is well-deserved. With a mass of 6.5 billion solar masses, it completely dwarfs the giants of our local group. Its event horizon is so large, it would engulf our entire solar system. From its center, it launches a jet of relativistic particles that extends for 5,000 light-years. For a long time, M87 star was our example of what it meant to be a truly massive black hole. It was the gold standard, the Leviathan by which all others were measured. And now, let's return to TON 618. Let's return to that fossil point of light that reaches us from the early universe. Its mass, measured through the echo of light in its accretion disk, is 66 billion solar masses. Let's put this number in the context of our tour. It is more than 16,000 times more massive than our Sagittarius A star. It is more than 300 times more massive than the giant of Andromeda. And it is 10 times more massive than the celebrated and colossal M87 star. The difference is not trivial. It is a fundamental category leap. To visualize it, let's use a weight analogy. If the mass of our Sagittarius A star were a glass marble, then the mass of Andromeda's black hole would be a heavy bowling ball. The mass of the famous M87 star would be a small car. And on this same scale, the mass of TON 618 would not be a truck or an airplane. It would be a naval destroyer, a steel structure of thousands of tons. They are not in the same category. They are not even in the same sport. The image we obtained of M87 star, that shadow that captured the world's imagination, is immense. But the event horizon of TON 618 is 100 times larger in area. The entire shadow of M87 star would fit comfortably in a small fraction of TON 618's darkness. This titan does not simply belong to the supermassive category. It belongs to a class apart, the ultramassive, objects so absurdly large that their very existence tells us that the early universe was a place capable of forging monsters on a scale that the modern cosmos rarely, if ever, matches. TON 618 not only wins the size contest, it redefines the limits of the contest itself. It is not in the same league as the other giants. It is in a league of its own. We have traced the anatomy of TON 618, measured its mass, and mapped the scale of its darkness and its light. But beyond the numbers and measurements, this object presents us with a profound philosophical paradox, an enigma that touches the very heart of the nature of the universe. We have described its black hole as the ultimate predator, a gravitational abyss that acts as the final tomb for matter, energy, and information. And yet, in the same breath, we have described its quasar as the brightest beacon of creation, a source of light and energy so powerful it can influence the evolution of entire galaxies. How can the same entity be at the same time the ultimate expression of destruction and an engine of such vast influence? To understand TON 618, we must accept that it is not one thing or the other. It is both. It is, in a single, magnificent entity, the cradle and the grave. First, let's explore its role as the grave. The event horizon of a black hole is the end of the road in the most absolute sense. Imagine a star, a magnificent sun that has shone for billions of years, perhaps warming a retinue of planets. If its orbit takes it too close to TON 618, its fate is inevitable. The immense tidal forces of the black hole, the difference in gravitational pull between the near and far side of the star, will stretch and tear it into a stream of incandescent gas. Its entire history, its majestic life as a nuclear fusion reactor, is unraveled in a cosmic instant. This gas is then drawn into the accretion disk, where it is superheated and consumed. Any information the star contained, its precise chemical composition, its internal structure, the history of its planets, if erased. Upon crossing the event horizon, all that remains of that star is its contribution to the mass and spin of the black hole. It is the annihilation of complexity, the triumph of entropy. It is a grave for matter, but it is also a grave for time. According to Einstein's theory of relativity, the extreme gravity of a black hole warps the fabric of time. To a distant observer, an object falling toward the event horizon would appear to slow down, its light stretching to red, until, at the moment of crossing the threshold, it would seem to freeze forever, trapped in an eternal instant. Time as we know it stops at the edge of the abyss. It is a grave, therefore, not only for matter, but for the very narrative of the universe, for the sequence of cause and effect. It is the definitive full stop. And yet, from the very edge of this grave, the cradle is born. The accretion disk, the violent funeral of matter, is also one of the most creative structures in the cosmos. The light and energy it radiates, with the power of 140 trillion suns, is not contained. It expands throughout the universe, and on its journey, it becomes a force for change, a catalyst for new beginnings. The powerful winds and relativistic jets emanating from the quasar are like the arms of a cosmic sower. They scoop up the heavy elements forged in the interiors of the stars being consumed. Carbon, oxygen, iron, the very elements that make us up, and expel them at incredible speeds, scattering them across intergalactic space. This process enriches the cosmic medium, seeding distant gas clouds with the raw materials needed for future generations of stars, and eventually planets and life to form. The death of a star in the banquet of Ton 618 becomes the fertilizer for life in another galaxy, billions of years in the future. Even the shockwave of this energy can be a creative force. Although the quasar's wind can sterilize its own host galaxy by sweeping away cold gas, when this wave of energy expands and collides with a dense, quiet gas cloud in a neighboring galaxy, it can compress it, triggering the gravitational collapse that gives birth to a new star cluster. The roar of the dying giant can be the lullaby of a new stellar nursery. In this way, the black hole acts as a cosmic redistribution engine. It is a recycler. It takes complex, ordered matter, breaks it down into pure energy in its accretion disk, and then uses that energy to scatter the fundamental building blocks of matter throughout the universe, fostering new creations in distant places. Ton 618 is, therefore, the perfect example of the duality that seems to govern the cosmos. It is neither good nor bad, neither creator nor destroyer. It is a system that encompasses both extremes. It is like a cosmic volcano. Its caldera consumes and melts the land on which it sits, an act of local destruction. But the ash it spews into the atmosphere travels around the world, and upon settling, fertilizes the soil, allowing new and lush life to flourish. Ton 618 is the cradle and the grave, united in a cycle of a scale and violence that overwhelm us. It teaches us that in the universe, death and life, the end and the beginning, are not opposites, but are inseparable partners in the great dance of cosmic existence. We have explored Ton 618 from the safety of distance, through the cold, abstract lens of physics and numbers. We have spoken of its mass, its light, and its history. But to truly feel its scale, for our minds to try, even in vain, to grasp its enormity, we must embark on one last journey. We invite you now to board a ship of the imagination, a theoretical vessel capable of defying the laws of time and space, and of withstanding the most extreme forces in the universe. Our destination is the heart of the beast. Our goal is to experience in a sensory way what it means to approach the most massive and luminous object we have ever known. We fasten our seatbelts for the impossible journey. Our departure begins from our small vantage point in the Milky Way. As we accelerate, our home galaxy unfolds before us, a majestic spiral 100,000 light-years in diameter, a swirl of billions of stars. But as the distance increases, its grandeur fades. It becomes a smudge of light, then one more among the archipelago of galaxies in the local group, and finally, it disappears, becoming an indistinguishable grain of sand on the vast cosmic beach. Our journey takes us through the intergalactic void. For eons, we navigate in almost perfect darkness, a blackness broken only by the distant passage of other galaxies, each an island universe with its own untold story. The universe expands around us, and the light of our destination, which began its own journey 10 billion years ago, finally begins to dominate our field of vision. Our arrival in the domain of Ton 618, billions of years after our departure, is unlike any other. We are not approaching a galaxy, a diffuse collection of stars. We are approaching a single point of light, a beacon of a blue-white so intense that it hurts our ship's sensors even from millions of light years away. As we enter the halo of the host galaxy, the glare becomes overwhelming. The sky of our cabin is no longer black. It is flooded with a perpetual, sourceless light. We see the ghosts of globular clusters and the streams of stars orbiting the lost galaxy, but everything is bathed in the glow of that impossible nucleus. Radiation begins to bombard our ship's hull. The shields activate, fighting against a torrent of X-rays and high-energy particles emanating from the system's heart. A few light years from the center, we enter the storm. We are navigating through the quasar wind, the flow of gas expelled from the galaxy by the sheer pressure of the monster's light. Our ship is buffeted by currents of matter moving at a fraction of the speed of light. The outside temperature rises dramatically. We are now close enough to resolve the source of all this energy. Before us extends the accretion disk. It is a structure that defies all description. A flat plane of incandescent plasma extending for a distance greater than our solar system. It is not a solid object, but a turbulent sea of matter in its most fundamental state, swirling at relativistic speeds. We see flashes and eruptions on its surface, magnetic storms the size of stars that are born and die in a matter of hours. The color is a blinding white at the center, fading to an orange and red at its cooler, more distant edges. We fly above this ocean of fire, protected by our shields, feeling the heat of a bonfire of 140 trillion suns. Our final destination lies beyond this disk. We maneuver our ship to leave the plane of the disk and approach the black hole from above, from its pole, to avoid the worst of the radiation and heat. And here, reality begins to warp. The immense gravity of Ton 618 curves space-time around it like a lens. A light from the accretion disk behind the black hole is bent and appears before us as a ghostly ring of light surrounding the central darkness. A perfect Einstein ring. The stars of the distant universe, whose light passes near the black hole, are deformed, their images stretched into luminous arcs. The sky has become a carnival of distorted light. Before us, the event horizon grows to fill our vision. It is a sphere of such perfect and absolute blackness that it makes the vacuum of space look gray in comparison. It is the total absence of everything. We approach the edge. Due to the immense scale of the black hole, the tidal forces are gentle. We are not torn apart. We simply float forward. The bright, warped universe behind us compresses into a small circle of light, the last window to the outside. And then, without a jolt, without a shake, without any drama, we cross the threshold. The circle of light disappears. Communication with the universe we left behind is severed forever. We are inside. Physics as we know it can no longer describe our journey. We only know that the direction is one, forward, toward the central singularity where the density and curvature of space-time become infinite. Our impossible journey has ended. Our ship, and all the information it contains, has become an infinitesimal part of the mass of TON 618, a silent tribute to the greatest giant in the cosmos. The impossible journey to TON 618, though an exercise of the imagination, leaves us with a visceral appreciation of its scale. But beyond the wonder and the spectacle, the real study of this object, through the faint, ancient light that reaches us, offers profound and fundamental lessons about the nature of the cosmos. TON 618 is not just a curiosity in the cosmic zoo. It is a Rosetta Stone, a natural laboratory that allows us to test the laws of physics at their most extreme limits and to reconstruct the history of a universe that no longer exists. The giant's lesson is not one, but several, and each one forces science to expand its horizons. The first and most important lesson is a fundamental correction to the models of galaxy and black hole formation. The mere existence of a 66 billion solar mass black hole as such an early stage of the universe is an anomaly that conventional models of slow, gradual growth tend not explain. Therefore, TON 618 acts as a gravitational anchor not only in its galaxy, but also in the theories of cosmologists. Any computer simulation, any new theoretical model that attempts to explain how the early universe evolved, must be able to produce an object like TON 618 in the correct timeframe. If a model cannot create this monster, that model is, by definition, incomplete. It has forced scientists to seriously consider the more exotic recipes for black hole growth. Ideas like the direct collapse of primordial gas clouds or episodes of hyperaccretion have moved from theoretical possibilities to logical necessities to explain the observational evidence that this giant represents. Secondly, TON 618 and its quasar serve as a high-energy physics laboratory on a scale unattainable for human civilization. The environment surrounding the black hole is a crucible where matter is subjected to the most extreme conditions of temperature, density, and gravity. The immense gravitational field allows physicists to test Einstein's general theory of relativity with astonishing precision, observing how the light from distant objects bends around it. The accretion disk, that vortex of superheated plasma, is the perfect environment to study plasma physics and magnetohydrodynamics in an energy regime that could never be replicated on Earth. The relativistic jets that likely emanate from its poles are the most powerful particle accelerators in the universe, launching matter at near light speeds and offering clues to the origin of the mysterious high-energy cosmic rays that constantly bombard our planet. Studying TON 618 is not just studying an object, it is studying the laws of physics themselves, operating at their breaking point. The third lesson is about the intricate dance of co-evolution between a black hole and its host galaxy. For a long time, supermassive black holes were thought of as passive objects, simple gravitational sinks at the centers of galaxies. The study of quasars like TON 618 has revealed a much more complex and dynamic truth. The black hole is not a mere resident. It is an active and sometimes tyrannical partner in the life of its galaxy. The immense energy released by the quasar during its active phase, through winds and radiation, has a profound impact on the entire galaxy. This feedback process can sweep cold gas out of the galaxy, halting the formation of new stars and determining when a galaxy ends its active growth phase and enters maturity. The lesson is that the galaxy and its central black hole grow together. The galaxy provides the fuel that feeds the black hole, and the black hole, in turn, regulates the future growth of the galaxy. It is a symbiotic and sometimes destructive relationship that shapes the destiny of countless billions of stars. Finally, the giant's deepest lesson is one of humility. TON 618 is a tangible reminder that the universe is capable of producing phenomena that lie at the absolute limit of our ability to comprehend, and in some cases, beyond it. It shows us that the early cosmos was a place of a violence and energy scale that dwarfs the relatively tranquil universe we inhabit today. The existence of such an inordinately large object serves as a counterpoint to our perspective, a reminder that our experience in this small, quiet corner of the Milky Way is not necessarily representative of all cosmic reality. It is proof that, no matter how much is learned and discovered, there will always be a bigger giant, a deeper mystery, a darker abyss waiting at the confines of knowledge. The final lesson of the giant is that exploration never ends. Our journey through time and space, from the familiarity of our solar system to the heart of the largest beast in the cosmos, comes to an end. The expedition through physics and imagination has taken us to the very limits of comprehension. The monsters have been weighed and measured, their anatomies of darkness and light explored, their stories deciphered from echoes and fossils of light, and the mysteries of their creation and eventual slumber contemplated. Now, after such a vast journey, it is time to return home, to return to our small, quiet vantage point in the universe, and see how this new perspective has forever changed the sky above our heads. This journey began with a reflection on scale, on the human search for limits. It started from the top of the highest mountain on Earth and ascended through planetary orbits and interstellar distances, until the numbers became abstract and the scale unfathomable. Now we return to that same perspective, but with new knowledge. We return with the awareness that in the tapestry of the night sky hides an object that redefines all those limits. In the discrete constellation of Canes Venatici, the hunting dogs, in a seemingly quiet area of the northern sky lies the fossil light of TON 618. You cannot see it. Even if you had access to the most powerful optical telescope on Earth, you would only see an incredibly faint blue point of light, indistinguishable from a distant, unimportant star. The monster is perfectly hidden, its true nature invisible to the direct gaze. It is a ghost in our sky, a giant disguised as a dwarf. The next time you find yourself under a truly dark sky, far from the orange veil of city lights, I invite you to an exercise of the imagination. Look up. You will see the luminous band of the Milky Way, the combined light of billions of neighboring suns. You will see the planets, wandering jewels in our own backyard. But then, look beyond. Look at the patches of darkness, the seemingly empty voids between the stars. It is in that depth, in that abyss, that the true universe resides, and in one of those patches of blackness, in the direction of those celestial hunting dogs, lies the echo of TON 618. Do not try to see it. Try to feel it. Feel the idea of its existence. Think that in that direction, a ray of light has been traveling for more than 10 billion years, carrying with it the story of a 66 billion solar mass black hole in the midst of a feast. The knowledge of its presence changes the nature of darkness. The void ceases to be empty. It becomes a history museum, filled with the echoes of events on a scale and of a violence we will never experience. To feel the conceptual presence of TON 618 is to feel the true depth of time. It is to understand that the universe had a youth, a wild and brilliant adolescence, and that you exist in its much quieter present. The era of great monsters like TON 618 is, for the most part, over. They forged the universe in which you live. Their winds and jets scattered the heavy elements that form your planet and your own body. Their violent feedback pacified their galaxies, allowing stable stars like our sun to form, and for life to have a chance in its quieter corners. You do not have to feel insignificant in the face of such a vast scale. Instead, you can feel a deep connection. You are the product of a universe that is large enough and old enough to have created such wonders. Your quiet existence is the legacy of its violent past. You are the conscious thought that the universe has generated, capable of looking back in time and understanding, however imperfectly, the history of its own titans. The abyss in the night sky is no longer a simple absence of light. It is a reminder of the immensity of time, of the incredible creative violence of nature, and of the ability of a curious mind on a small blue planet to reach across the eons and touch, if only with the imagination, the edge of the largest object of creation. And with this thought, with this new and profound perspective on darkness, you can simply observe. And let the immensity of the cosmos lull you to sleep.